SafeCap project aims at developing modeling techniques and tools for improving railway capacity while ensuring that safety standards are maintained. This video demonstrates the SafeCap Platform version 2. The platform allows engineers to construct and reason about railway schemas. It provides a schema editor, a project explorer, and a number of views for editing properties of schema elements such as railway segments, junctions, train tables, etc. The tool is based on Eclipse and uses EMF, GMF, and Epsilon frameworks. In this demonstration, we will show the process of schema construction, safety verification, and capacity assessment and improvement. Firstly, we will show how to construct a simple railway schema. We start with creating a new SafeCap project and a SafeCap diagram. We construct the schema topology using nodes and segments. Segments represent railway tracks. Typically they correspond to train detection circuits. Nodes represent circuit boundaries and points. Every segment has two nodes on its ends and is characterized by its length measured in meters. Then we can add elements of trackside equipment such as speed limits and signals and platforms. For a given topology, the tool can produce logical elements. These include lines, routes, and ambits, that is, train detection circuits. Having defined the schema, we proceed with its safety verification. The tool verifies the topology of the schema, control tables, signals, and speed limits positioning. The properties being verified include absence of train derailments, absence of collisions, etc. Let us open a control table for this schema and deliberately remove a train detection circuit required to be clear by a route. Now we will try to verify the control table for this layout. We can see that the verification tool fails to verify the control table and provides some feedback on the failed conditions. We can now fix the problem and try to verify it once more. The verification is done by translating the layout and the control table into a B formal model, which is checked by the Pro-B model checker. Here we will demonstrate how to use the tools available in the SafeCap platform to improve the capacity of a layout. The example is a station layout with 4 platforms and 2 one-way tracks. The bottom 2 platforms can only be used by the trains going from left to right, while the top 2 supports both directions. There is a mixed traffic going through this layout. The service pattern defines the types of trains and the times of their arrival. There are 6 passenger trains that are colored in red, green and blue, and 2 freight trains that are shown in black. Firstly, we run the simulator, which produces all the necessary data for further analysis. It also shows simple distance of time functions for all the trains. The most important number that we obtain from this window is the overall time that it took for the trains to pass through the layout. We will use this value as a measure of capacity for a particular service pattern. The simulation replay view can be used to control the replay of the simulation to observe the movement of the trains through the layout. During replay, the same editor that was previously used for layout modeling is now showing the simulation results. We can see the trains, their current speeds and braking distances, and current states of signals. The simulation replay view also provides useful information about the behavior of the trains. Now imagine that we are given a task to find a time slot and possibly optimize the movement of trains in order to allow one more freight train to pass from left to right. Note that most of the time all 4 tracks are occupied. There is a short time window available on the top track, but the trains going from right normally reserve these points and the available time slot is not enough for a freight train to pass. However, it could be just enough for a passenger train to pass, and we shall use that opportunity and direct one of the trains through a different route. First of all, let us see whether the current layout has any bottlenecks and whether it can be improved. We can see that at the time 240, the green train departs from the platform and has to wait for the freight train to pass. The heat map is a useful tool that can indicate potential bottlenecks or inefficiencies. It colors the layout segments with the so-called heat, that is, the overall time that a particular segment has been occupied. Hot segments, which are shown in red, are of particular interest as they typically indicate the points at which trains wait or accelerate slowly. At the moment, the speed of the freight train is mostly limited by the fact that the routes are quite short and the signals only have two aspects. We shall modify the control table and switch the signaling to three aspects for this line. To do this, we select a route and switch the control rule associated with a particular line to custom mode. This allows us to define control tables for a particular train, while other trains would still obey the default signaling defined for the layout. We run the simulation again and observe that the overall time of the service pattern is reduced. The freight train and the green passenger train now leave this area much quicker, which provides us with an additional time window. The next step is to reroute the red train to arrive at the top platform. This will provide a free route in the middle for the new freight train. We define a new train in the service pattern and run the simulation again. The overall time now is slightly better than the time for the initial version, and we managed to add another train to the schedule. The platform provides a tool for showing block diagrams. This tool can be particularly useful for analyzing and reducing the train headways on a single line. Another notable capability of the SafeCap platform is the customizable architecture. It provides a means for creating and applying custom scripts. These include capacity assessment scripts, layout modification patterns, and verification scripts. The existing B generation script is one such tool that is considered by the platform as a user-defined tool.